Austin, you want to come up and do yours?
Well, I can find my plan, but I can't find it on Google Maps.
Oh, really?
Yeah, like I can find a web page talking about it.
Okay, does it have a picture of it?
It has pictures of the front of it, not the top.
Okay, let's find one we can see from the Google map. And maybe send me that link and I'll try to help you find it, all right?
Okay.
So how about Kyle, you haven't been up yet, right?
I have not been.
Come show us what you got. I called up Bo last time, right? Yeah, go ahead, here's the brown. All right. Okay, and I'll erase the board here to get it ready so you can draw the diagram for us. The James River. Whoa! Whoa! This is cool. Where is this?
Richmond, Virginia.
Wow, nice. All right, tell us what you know about this plant here. Or why don't you come and start drawing the diagram, and we'll kind of point out what we've got as we go. So what are you going to start with?
Source.
Is it the James River?
Yes.
Okay. Wow, this is cool. Are you sure this isn't like some distorted image or something?
Yeah, it really curves like that.
Huh. That's amazing. I gotta mark this one down.
They really wanted that plot of land. Things look like it's only like a kids. They had to like squeeze every inch out of it.
Start. Actually, so this is a good example of a plant that is bound, right? It's got these clear boundaries with the, it actually looks like a railroad track there. Railroad track, this is a good satellite image too. So it's got the railroad track and it's got the road on the other side, and I assume someone else owns the land on the other side of the road, so they couldn't just get rid of it. And they just squeezed it in there. That's pretty cool.
Pretty good stuff.
Oh, did you see that? Look at that. See how this is all brown right here? And this is blue or green? And then you zoom in and the brown goes away. That must just be they had these out of service in the satellite image. You know, they pieced together a bunch of images, right? So here's the satellite image split. And this one was out of service when they took this picture, but it was in service when they took the other picture. That's my guess. Cool stuff though, you know, this right here. These are interesting too. Good stuff. This is a bizarre plant.
Sorry. They have aeration too, which is kind of interesting. I'm not really sure
Yeah.
what it's doing. I read on the website it was like to improve taste and quality, but it didn't get into why they do that.
Okay. All right, well tell us,
It's a big picture.
or you got your diagram here?
That's my little house.
I'm gonna have to go to this plant one day. It's long.
It's really old too. I think it's like 90 years old or something.
Okay.
So that might even kind of why it's weird.
Okay. So tell us, where's the coagulation? Any idea?
Somewhere there, probably.
Okay. Flocculation?
Population. Right there, probably. It's
All
flowing this
right.
way, so.
What's that?
It's flowing this way, right? So
Well, I don't know.
I think so.
Think so?
The river
All right.
flows that way, so that would make sense.
That would make sense. All right, flocculation, sedimentation. pretty clear. Filtration?
Right. I'm not sure what that was. It looked like they were kind of like gates in those.
Yeah, okay.
So
And disinfection?
somewhere, either before or after the aeration, I guess.
Okay, interesting. And then aeration. Wow.
Yeah.
Very cool. Very cool. All right. Does anyone disagree with what Kyle just came up with, or have any thoughts about like how can we know? How can we make some guesses? Let's look at this one right here.
So first part that you pointed out, that kind of look, those right there look like walkers maybe.
Don't they look like launders?
Yeah, they kind of do, which kind of, yeah.
So which direction? We usually wear the launders
At the end of the
at
subject.
the end of sedimentation.
Right.
So that's what's got me baffled. And to be honest, these look like
That was like.
like, yeah, flocculation chambers. And this is where we like, usually we would have these walls to sort of increase the turbulence or to tailor our G value. But these look like pumps, and you can have actually vertical flocculation chambers or flocculation paddles too. We talked about the horizontal ones, and that's what we saw in our plans. But you can have vertical flocculation paddles, and that's what I would guess this is. So it's really weird because this looks like filtration right here. Like all these different
Right.
walkways, these look like a bunch of sand filters. And then the aeration, I would expect it would come at the end, I guess. We don't talk about aeration much, so it can come either before or after. As far as disinfection, you're gonna wanna put your disinfectant probably after the aeration, because if you aerate chlorinated water, you're gonna lose a lot of your chlorine just to the air. So I'm not sure. We're gonna have to investigate this further, I think, and try to figure out like how does the water flow, because it almost looks like if it comes to the middle first and flows this way and then comes back over here.
Yeah.
And I know that's bizarre, but it's a bizarre plant anyway. It is cool. All right, good. So thank you.
Would they have just done that to fit the footprint since it's wider up towards the top?
Definitely. I mean, that's what they did. They did it to fit the footprint. But the question is, how does the water flow through that footprint? Because it looks like this is flowing this way, and then this would come at the end. So maybe they did that. Maybe they said, okay, we're just gonna have to make it flow this way and put it in a pipe and bring it back here, because this is the small part of our, this is the small part of our land, and the filters can be in a smaller footprint. But I bet some engineers said, all right, we could start at that end and have it flow this way, but what would be the advantage to flowing it this way for your sedimentation basins?
Area.
What's that?
You have like more area at the end. I don't know if that helps.
More area at the end, which means less velocity. If you squeeze it, you're gonna get faster flow rates at the end. So it does make sense to have your sedimentation go toward the big end. Yeah, we're gonna have to give them a call and ask them. And say, hey, we were looking at your satellite view. Got a couple questions for you. All right, the main reason I wanted to have Kyle come up and do that though is to help us see this diagram again and to realize that now we're at disinfection. So this class has been about, we talked about source water quality, we talked about coagulation, flocculation, sedimentation, we talked about filtration. We took a little side road to talk about membrane filtration, which is a different type of filtration. Then we took another side road to talk about lime softening, which is a special case when you have calcium and magnesium, right? And we took this other side road to talk about reverse osmosis and nanofiltration. But again, those can fit into this conventional diagram, right? Now we have finally arrived at disinfection, our penultimate topic for the course. The funny thing is, had we done this course chronologically, then we would have started with disinfection. And I think I've said it a few times, but I'm going to reiterate again. Disinfection is really the main purpose of the whole water treatment plant. And we're going to see the history that helps us